Good morning.
Uh, where'd the other guy went?
He got fired. He's not adequate enough. You see?
Oh,
He dissed this thing, so we fired him. The production crew.
I see. That's rather unfortunate.
Good morning, everyone. My name is Olive,
I'm Ian,
and we're going to tell you guys, explain about
non-fossil fuel energy.
and non-fossil energy.
So, fossil energy, as the name explains, fossil energy comes from, you guessed it, fossils. So, to elaborate what this means, fossil are dead animals and plants that were buried millions and millions of years ago. So, there are many types of fossil fuel, but we'll get to the first one. There are two types in the first one. There is petroleum and coal. So, coal is formed when dead plants get buried millions of years ago, and because of erosion and everything, they get buried under dirt, as we sit on right now. And inside of the dirt, the Earth's pressure, the Earth's heat and time pressurizes these dead plants, and in turn they get carbon. And after millions of years, coal is formed. There are four types of coals. There are, the first one is lignite. The color is rather brown. It's not really black.
Not so much carbon content.
Not so much carbon content. It can be used as fuel, but it's not really worth it. The second one is subbitumen. It's starting to turn black, but it's still like anthracite. No, it's just like lignite, but yeah, still. This third one, bitumen. Now, this is where it gets interesting. It starts to get black, and its carbon content becomes higher, thus it burns longer. And the final part, the final version of coal, is anthracite. It is black, it is dark, it is good.
So, like, it gets blacker, like, the deeper it is, right?
Yes,
Ian?
yes. As it goes deeper, it gets darker, blacker. You get it. And the other type is gasoline. It's petroleum. It's petroleum. Petroleum is almost like coal, but instead of dead plants, this time it's dead animals, and it's under the sea. There's a big factor here. The other one is on land, and the other one is on sea. When dead animals die, they sink to the bottom of the ocean, and through the process, they got buried. Pressure, heat, time, they turn into petroleum and gas.
So, are you saying that there's like the gas part and the liquid part?
Yes, there are two. You can extract the oil and you can extract the gas. Where there is gas, there is always oil. Keep that in mind.
Let's move on to non-fossil energy. As the name suggests, it's not from fossil. So there are like a few characteristics of a non-fossil energy. The first one, it's renewable. So like no matter what, the supply won't run
Yes.
unless Earth explodes. Yes. And the second characteristic is that it has a cycle. So we're going to discuss 5 types of non-fossil energy. There's water, air, solar, biomass, and geothermal. So the first one is water. You guys know that there's a water cycle, the short, the medium, and the long one. So water energy can be found in water reserves such as rivers, lakes, and waterfalls. The thing about non-fossil energy is that you can't just use it directly. The only thing you can do about non-fossil energy is you have to convert it into another energy that we can use. So how do we convert water energy into something that we can use? We can use turbines, like under the waterfall. You know, like waterfall,
Those inside of dams.
yeah, they have the turbine. Like the movement of the water will like spin the turbine, and that kinetic energy will be converted into electricity that we can use for our lights, for our shower, heater. And the second one is air, as in wind. So, this is air, right? But to make energy out of air, we need movement. And movement from air, we need pressure. What we learned from geography, I'm gonna explain it. There's this principle, there's this rule that wind, angin, will come from a colder place to the
Hotter areas.
to the hotter areas. Let us talk about angin laut and angin darat. Let's say in the siang hari, during the daytime,
right now.
yeah, there's let's say this is sea and this is the surface. Because sea is water, sea is made out of water. It's really hard for it to get hot. So the sea will always be cold during the daytime, and then the land will always be hot during the daytime. So during the daytime, wind will always come from the sea to the land, and during the nighttime, that's when the surface finally cools down because there's no more sun. But on the other hand,
The sea becomes hot.
it becomes hot because it starts releasing all that heat that's been pent up during the day. So during nighttime, the wind will always come from the land towards the sea. How do we use wind pressure? Yeah, it's similar to
Similar to
water. Yeah,
we use the turbines.
yeah.
The earliest usage of wind power is at Holland,
Yeah.
Dutch. Holland Bakery, the windmill.
Yeah. Solar energy. Solar energy comes only one source.
The sun. It's so bright.
Yeah. Today's a very sunny day.
Sun.
Yeah. So we use the heat from the sun to supply us with electricity. But how do we convert it then? So you see,
Solar panels.
yeah, people use solar panels. It's like this
Blue flat plank.
blue flat planks that absorb heat. They will contain the heat inside this battery thing and convert it into electricity. And from this battery, they will yeah. These days, solar energy is really very
Very useful.
very
But
useful.
it's an expensive source. No, it's expensive to create it. Solar panels are not really accessible to people with lower economic standards. So it's quite expensive per se.
Yeah, but in this era, we can see that solar panel has been used commonly. Now they have those RVs for camping.
Ah,
Yeah, these days they have a solar panel. So if you go to an isolated place for a few days, you don't have to worry because the car will move with the solar power energy, with the energy from the sun.
don't have to worry about fuel.
Yeah,
I forgot to mention, this is a bit arguable, but nuclear energy, it comes from radioactive materials such as uranium. Well, anything radioactive you could use as nuclear energy. But why is this non-renewable? Because you couldn't really find uranium once it's gone. It kind of comes from space.
yeah,
It's basically space rock. But on the other hand, it's quite renewable because once the element of choice that you use fades away, you could still see smaller particles. It is theorized
The
that
waste.
the waste.
Non, rien de rien.
Could collect it and create another plutonium or whatever. So
we
it's
can use the waste
yeah.
again.
Yeah.
So some scientists they think that uranium is, nuclear energy is renewable.
It is very good source of energy. It runs well, but it's quite dangerous. Bad example is Chernobyl.
Yeah,
Something bad happened there. Chernobyl is still radioactive up till this day.
a nuclear plant exploded,
RIP.
and
Fukushima as well,
one
Japan.
whole city is it's so radioactive.
Isolated. Everyone had to evacuate. It's hell. It's radioactive
Would
zone.
you like to mention a few side effects of getting that radioactive
Radioactive?
energy?
It has very severe effect on body. It deforms body. It can easily kill you, and it really messes up with your body. So you don't want to come in contact with radioactive things.
Not only that, for women, if you get that radioactivity, you won't be able to get pregnant.
Nice.
Yeah, guys too, you won't be able
Oh.
to impregnate.
Oh, it destroys your fertility function.
Yeah.
So be careful.
They say that it causes some animals to mutate.
Oh yes, you could see very strange mutations in Chernobyl. Strange colors start to appear. Their body becomes larger, maybe a bit smaller.
They got scarier.
Yeah, they got scarier basically. Don't go to Chernobyl. It's
Yeah.
accessible, but don't go to it.
Let's move on to geothermal. So it's also similar to solar, but then the thing solar comes from the sun
The sun.
up, but geothermal comes from below,
The heat of the earth.
the heat of the earth. So you guys know back in grade 10 we learned about there's the astrosphere, and there's the
The
aquifer.
layers.
Are you recording?
Yes.
I've already interrupted. I'm sorry. Can you
Oh.
fill that in? Give it to Miss Mike. Start first break. Really
Okay.
important.
Thank you, sir. So
Sorry.
it's okay.
Best teacher.
Where were we?
Geothermal energy.
Oh yes. So how
The
do
layers.
the layers?
Yes.
So there's heat from the earth on
Yes.
us, and the heat it goes up, right?
Yeah.
But then like there's this layer like that protects us from it,
The mantle.
the mantle
The earth's. No, sorry. It's the earth's crust.
crust.
The
there's-
thing we stand on. We stand on crusts or tectonic plates, if you would like.
Yeah. But then like it always goes up, so obviously there's always that heat. So what we do, how do we get this geothermal energy? We put in pipes.
Yes, pipes.
We put in pipes,
Insert pipe
insert pipes,
onto earth.
we suck it.
We suck the energy from the earth.
And then, but it's not as simple as that.
Yeah.
We have to like cool it down because
Yes.
energy from inside the earth is so hot that like we have
It could melt.
it could melt the pipes.
So
You have to have like a good cooling system.
yeah, a good cooling system.
If you see the geothermal station in Lampung, there's a lot of smoke, but that smoke doesn't come from down there. It comes because heat.
Cooling.
Yeah, because of the cooling process, heat mixed with water, evaporation.
It creates steam.
It creates steam.
The air is not poisonous. You could actually breathe it, but I wouldn't suggest that. It hurts your lungs.
It's actually very beneficial for Indonesia to like use geothermal energy because we are located in the ring of fire. We have a lot of and two tectonic plates. We can make use of that, but too bad our technology is not sufficient enough yet. We'll see later in the future. And the last one we're going to discuss about is biomass. So biomass comes from garbage, animal poo, human poo, anything related to animals, like
Waste.
the waste. So what we do is contain
In a box.
in a box or like underground, and then like was it methane?
Methane. Yes.
Yeah, methane. It will like start.
We burn it. We burn it. We burn it.
The what?
The waste. It's methane. Through methane.
Yeah, or like in the process of decomposition, you
Yeah.
can get that gas, and and we can use it for, you know, LP, like as for cooking. We can use it for heating our water too. There's actually two types. There's bioethanol and biodiesel. So there's like a difference. Ethanol, it comes from fermented waste. We get the methane. I mean, like we get the product, and it's way more clear than other gases. Yeah. So bioethanol energy comes from the fermentation of methane, and it's way clearer than most fuels. We can use it for cooking, heating,
Daily appliances.
the appliances. And the second one is biodiesel. Biodiesel comes from the fermentation of seaweed and vegetable oil. Yes, vegetable oil. And same again. We can use it for
Everyday usage. It's a different version basically. You could use whichever you want.
But then, like, out of all these non-fossil energies, of course, there's like the plus and minus. Let's discuss that for a bit. Starting from our latest discussion about biomass. It may be good. It reduces energy and it's renewable. But the thing is,
It stinks.
it stinks. It gives air pollution because it stinks.
Methane.
The methane,
Methane
carbon.
stinks.
How about solar? Solar expensive.
Solar is expensive. We said it before. It's expensive to manufacture solar panels. Very
Yeah.
costly.
Water. Like when you put turbines inside a water ecosystem, inside a lake or inside a river, it can damage.
It's clean ecosystem.
Yeah, it can like just imagine turbine and then like
A fish.
a fish swims right in. Gosh.
Dead. Rip fish.
They can also destroy the plants inside
Yeah,
the river.
it destroys plants. It basically destroys the ecosystem. Not necessarily destroy, harms the ecosystem around the river, lake, or anywhere you put your turbine.
Like what is it? The ones that there's also turbines inside the sea, right?
Yeah.
Yeah, that's even worse. Corals, guys, coral reefs.
Yeah.
Oh,
They take millions of years to create, and we just destroyed them.
just imagine like dolphins swimming into the turbine.
There are many cases. I have personally seen the ones that are on the sea. They just stand there, and at the bottom of them they have turbines, right? And in many cases, you can get fishes swimming into your turbines and rip fish again.
Well, not only that, it's very expensive and it's
Yeah.
not applicable for every country.
Yeah, it's not applicable for every country.
It's only applicable to countries that have a lot of sea.
Have a lot of sea current.
Yeah. And then what else? Water, air is also pretty expensive.
Air is pretty expensive. It uses turbines. There are also cases where the turbines get hit by lightning, and it takes a lot of money to repair them.
It can also destroy
The birds,
Bird
yes.
ecosystem?
Bird ecosystem. Aerial ecosystem.
aerial ecosystem.
Yeah.
Also, it's not applicable. There are windy days and non-windy days.
Yeah,
Right?
yeah.
It's only effective during
The windy days,
Yeah, during
yeah.
the windy days. What next?
That's it.
Geothermal.
Oh, geothermal.
Again, it's not applicable for every nation.
Yeah.
There are some countries that don't even have volcanoes.
Yeah. Like middle European countries, they couldn't use geothermal energy.
True. It requires a lot of technology.
Yeah, it requires a lot of technology, a lot of money. Again, most of the renewable resources that we could use require a lot of money because we really don't have the technology to easily develop something like that on a massive scale.
Yeah. So I guess that's it for today, Ian. Thank you.
Thank you.
You guys, I know this is so sudden, but there's no interruption. Why? Because we have an adequate MC now. I'm like the other guy from before.
One like equals to one prayer for Eppen. Pray for Eppen.
Thank you guys.
Thank you guys.
Bye-bye.
Bye.